that excitement is already building up. The last two speeches, but I'm inspired. So what I want to do briefly, we don't have that much time to speak, but I'll try and compress a bit into it to sort of continue on that level of energy that we've got going right here. It's fantastic, and I think it's just going to get better and better. So I work for McLaren. I do have probably one of those dream jobs that people really think that must be really the hot seat in design. I work at McLaren, which is a pretty reputable company in racing and not so well known in the automotive sector as a road car division, but that's exactly what we're doing now. Is we're building up a whole new range of cars that will sit at that high-end level of the supercar market, which is the Lamborghinis and the Ferraris, Porsches, Aston Martin. So it's a real challenge for us to compete in that market and to gain the trust and make people understand that we're really serious about it. So we're really not going head-to-head with these guys. Our goal is probably to be a little bit higher than them, to not overpopulate that segment, which is really no reason to come back into the business unless you're going to offer something probably on a slightly different level. So that's our challenge. We're, like I said, involved with racing. We're doing road cars, and we've been hooked up with racing, all kinds of different classes throughout the last 40 years about. We work in a place that is simply incredible. I can't really begin to tell you the excitement level of just driving into the place every morning and the awe that I have when I just walk into this place. It's a Norman Foster designed building and very much based on the symbol of yin-yang, where the lake and the building itself work together for different reasons. But inside this place, it's just something out of, it's not even a Starship Enterprise or James Bond. It's something of a mix between the two. It's just 100% inspiration from the moment you walk in. A bit intimidating the first few weeks because you think that's, I don't think anybody really is used to working in an environment like that unless you're in some kind of film or science fiction story, because it really does give you that impression from the very first moment. Like I said, we're really a racing car company. We go back to the late 60s and around that era there, but really started to take off from McLaren was we introduced to the Formula One, to the racing world, the use of carbon fiber. And it's almost the same. McLaren equals carbon fiber. We took it from the aeronautical industry, where it was sort of the wonder material in terms of strength and lightness and these things. And Ron Dennis, our CEO, had a brilliant idea of using it for racing cars. And we all know that now you can crash at 200 miles an hour and just walk out with a slight headache. So it really is the super material we're using these days. There's a lot of talk about it, different uses, but what I think we're trying to do is really bring it down into the more mass market volume areas of the segment of the road car business. We started using it in the mid-90s in our road car, the F1, and we built the central tub around it with carbon fiber. And if I give you a relative number, it was about 3,000 hours to build the tub on this car. Of the 100 that we built, it was just roughly over 100 models of the car. So from 3,000 hours to build this tub, our next road car was the SLR, sort of a combination of Mercedes and McLaren working together. That was cut down to 400 hours to build the tub, and still very high intensity or a lot of manpower to build the tub, and very, very expensive, not really useful for the volume market segment still. And now on the P4 12C that we're actually working on now, we've reduced it to 4 hours, and that's pretty incredible because from 3,000 hours on the F1 to 4 hours on the 12C is a huge difference, not only in time but in cost. And then also the technology is advanced pretty far, such that the tub that we're using now on the 12C is a complete new technology, a new way of using it. It's a one-piece mold, and it's a hollow monocell, so it's extremely, very light, and we can see the trend is going to be just keep coming down and getting into the sort of daily cars. So what we've done actually is build the car from what we call the inside out. I know a lot of people say that, but we really have. If you look on the right side, this is pretty much the optimized engineering package that we were delivered from engineering. and we had to, of course, work on the hard points and develop a chassis, a frame or a style around that package that gave the impression of what McLaren's should look like as a road car. So we weren't really held back with what our historical DNA was sort of driving us to do. We just took it from sort of a mechanical look of what works and engineering-wise, and then sort of reskin that and keep the skinning almost to a sort of a shrink-wrapped feeling. So the car visually is very, very light, and physically also, of course. These are a few cars that I've been involved with, and the transition from the kind of technology we use to develop them, for example, the first car with the RS Cosworth to today with McLaren, the kind of technology we've used to design cars, and just, for me, it's been mind-blowing. I could never have imagined back in the late 80s that computers would help us that much in doing this type of design. We, of course, back in those ages there, we were much more leaving the design up to the designers for a much longer part of the design process, then handing it over to the engineers or to the guys who were in control of taking it into production. And there was always that sort of not very good meshing of the cogs, where you got a lot of conflict between design and engineering, because suddenly they were supposed to, or expected to turn a car out that resembled very closely your design model, and of course the friction there was stimulating, but it's not very productive in the end. What we've tried to do throughout this whole history, what we've really accomplished lately now is move the design and engineering much more closely together, integrating engineering with designing as close up as possible to the very start of the whole process. Now, I know a lot of people are thinking that that really hems into creativity and sort of doesn't give you the chance to be free and to have all these crazy ideas and then let the engineers work on it. But that is precisely why we're going to be able to do cars a lot faster. And I think the fault really doesn't lie with the designers in the first place. It lies more or less with the engineers. And I'm not criticizing the engineers, but what I'm saying is that if the engineers are as creative as the designers, if they have that sort of enthusiasm to bring out something that's innovative and not so much, well, we haven't done it that way before, the costs are prohibitive, or it's a big risk for our timing schedule. If they're more trained in the way that, sorry to say this, but the way the McLaren design engineers are trained, which is innovate, innovate, innovate. Each week, each Formula One car, we see about 300 modifications somewhere along the car before the next race. That kind of drive to innovate is really what helps designers and engineers really to be able to be on the same wavelength. So if you get those crazy designers working with those crazy engineers, the product is going to come out much truer to the initial design themes that you were hoping to get. So those concept cars will still look like concept cars when they come out into production, which is good for everybody. We, like I said, are concentrating right now on delivering this car here. This is the 12C to the worldwide markets. We're actually right now in different countries around the world doing dealer launches and sort of setting up the network. It's an extremely, extremely exciting project to be on, because it really is a white sheet piece of paper. We've cut off from Mercedes earlier last year. We've developed everything to be bespoke on this car. And the design process, like I said, has been very, very quick on the car. I started halfway through the project, so I wasn't able to have 100% freedom on it, but I stand behind it 100% because we have changed a few things that have made a big impact on it, kind of late in the design cycle, but that's all attributed to the way we've been able to design on computers, and I'll show you that in a second. So obviously we went from the sketch phase to selecting the final theme and then transferring that to the mathematics, and then of course doing the visual rendering process with 2D, and then representing different model versions, different colors, different accessories, animating the parts of the car that had to actually show how they work. This is our air brake. It's not a spoiler, it's an air brake. And then at the very, very last moment, going into sort of a fees phase where you have the model done in clay to back it up and to sort of make sure that all the surfaces are correct and highlights are running well. So that's pretty much the very, very quick way of doing a car. Now, it can't be much faster, and that's what we're doing today. The future, that's difficult to say. Nobody really knows. If you ask the guy, go back.